Let's learn about Charles' law. So if you take a look at these two buckets basically filled with water, one is filled with cold water, the other is filled with hot water, and you have a balloon with the same number of molecules, that should have, that's 5, let's add another one out here, okay? So you have a balloon with the same number of molecules. In the hot water, what happens is these molecules have more kinetic energy, okay? So I'm going to call kinetic energy Ke. Kinetic energy is high because with the temperature, the molecules just want to move around real quick, okay? And then when you take that same balloon and you transfer it to cold water, what happens is the balloon shrinks because the kinetic energy is low, so they're not pushing against the walls that hard, okay? So out here, kinetic energy is low. So as a result of this, what happens is, notice carefully, this balloon is significantly smaller than that. Therefore, we saw that out here, your volume actually went down, okay? And then what else went down out here? Temperature went down too because it's cold water. So the temperature goes down. So it turns out, but what we kept constant out here is we didn't change the pressure, we didn't change the moles, okay? So if pressure, excuse me, and moles is constant, then the volume and the temperature, they go in the same direction. So if you drop the temperature, the volume will go down. If you increase the temperature, the volume will go up, okay? And that's exactly what Charles' law is. So to put this in a mathematical context, we can write V is directly proportional to T, because as V goes up, T goes up. As V goes down, T goes down. And then if you remove the proportionality sign, we can say V is equal to a constant times T, okay? And then if you bring the T on the left-hand side and keep the constant on the right, we have V over T is equal to a constant, okay? So now if you have two different situations where you had a balloon, for example, in this case, you had the balloon, it was sitting at a certain temperature, let's call the temperature 1, and then it was sitting at a certain, corresponding to the temperature, it was also sitting at a certain volume, let's call that volume 1, and then you took the balloon from the cold water, put it in the hot water, now the temperature went up, so that's 2, and now the volume also went up because the balloon expanded, and then that's 2, okay? So we can take those relationships in the two different conditions and relate them to each other using Charles's law. And Charles' law basically says since V over T is equal to a constant, if we keep changing it, so we can do V1 over T1 for the first set of conditions is equal to a constant, and that constant is also equal to V2 over T2, which is V2 over T2. And so if we just remove the constant, then this becomes V1 over T1 is equal to V2 over T2. And there you have it. Now you have an equation that can be used to solve a lot of different problems where 3 variables are given to you and you only need to solve for the 4th one. One thing to note and keep in mind out here is that the temperature, when you're using Charles' law or pretty much any gas law, the temperature should always be in Kelvin, okay? So I'm going to put a little asterisk out here. Maybe I'll put it in red out here so we'll always remember it, okay? The temperature should always be in Kelvin, okay? And typically the temperature will always be given to you in degrees Celsius. So when you have temperature in degrees Celsius, I'm going to put T in degrees Celsius. You want to add 273.15 to it to give you the temperature in Kelvin. All right? I hope that made sense.